Welcome to today's session, Achieving Scalability and Performance with VMware Virtual Volumes for Oracle Workloads. My name is Sudhir Balasubramanian. I'm a Senior SAP Solution Architect and the Global Oracle Practice Lead for VMware. I'm joined by Jason.
Hello, Jason Massey. I'm a technical marketing architect for storage and vVOLS.
Thank you, Jason. All right, let's move on. And this is the agenda for today's discussion. Essentially, we start with introduction to VMware Virtual Volumes, and then we talk about traditional challenges for virtualized business-critical databases. We'll talk a bit about some of the use cases for vVOLS and Oracle, and then end that up with a couple of takeaways in conclusion. And let me hand this now over to Jason.
All right, thanks, Sudhir. So today we're going to give you a quick overview about vVOLS and kind of how they work and what they are. So let's run through this. Next slide. So first and foremost, when you think about vVOLS, a lot of customers that are interested in vVOLS, if you're not familiar with it, or familiar with how vVOLS work, is what are vVOLS? So go ahead and build the slide out. There's the first thing that you think about is vVOLS. The easiest way to think about this is they're well orchestrated RDMs. Now, I know a lot of customers don't necessarily like the term RDM, right? That's kind of become almost something that a lot of customers don't like to use, but it's used for specific reasons, right? There's a lot of things that you have to use an RDM for. One of them is the Microsoft WSFC and some of the Oracle implementations, which is what we're going to talk about today. But when I say that they're similar to, the idea is each vVol object is its own entity on the array itself. There's actually no file system. So if the virtual disk is sitting on the array, whatever the virtual guest OS is inside that disk is actually the file system that's sitting on the array. So if that's ext4 or NTFS or whatever that might be, that's the actual file system sitting on the array. It's not sitting inside of another file system like VMFS or NFS or something like that. So that's where you get that similarity to an RDM. Now, with that, there's some benefits, because stuff like space reclamation, instead of it being passed down to another file system, the file system processing that and then sending it to the array, if the guest OS actually does an initiative like trim or unmap, it actually gets passed directly to the array. So you get very efficient space reclamation with vVOLS. Another big benefit, and this is where the storage admin really gets a lot of benefit, is that there's no more provisioning of LUNs or volumes. All of that process is handled with the vSphere automation around vVOLS. So when you provision a VM and there's disks attached, vSphere actually creates those objects for you. So you don't have to go create a LUN or a volume for a new VM or for a data store. Once you set up vVOLS in your environment, all of that process is handled by the automation. And another big benefit as far as managing storage capabilities is, again, instead of having to provision multiple data stores with different storage capabilities or even replication, all of those functionalities are available in a single vVOLS data store. On the vSphere side, it looks exactly the same as everything else, but on the array is really where the storage admin is going to see the difference and a lot of benefits in that. And then there's one more after this, and that includes the replication. vVOLS allows VM level array-based replication. So instead of doing replication at a LUN or a volume level, which replicates everything that's inside of that LUN or volume, you can now use policy-based management to associate a single VM or a set of VMs and replicate only that subset of VMs. Again, all managed by policy-based management. So let's go to the next slide. So really, when we start thinking about kind of how they work, vVOLS, if you were to take a VM with a traditional 2-disk setup and you put that in a single data store, both of those disks are going to have the same storage capability. If you want to change the storage capability of a single disk, you actually have to separate the disks into separate data stores. So one data store might have one storage capability and another data store might have another storage capability. Now, that's completely supported, and we see lots of customers that do that, but it adds a little bit more complexity to the environment. Now, when we look at vVols, go ahead and hit next. That complicated mechanism of having to separate these goes away, because like I said, you can manage at either the VM disk or the VM level the storage capabilities. Now, when it comes to replication, it is at the VM level only. You can't do a specific disk. But the big difference here is that same VM with two separate VMDKs can have different storage capabilities on each VMDK sitting in the same vVols data store. So they no longer have to be separated and reduce that complexity of separating your VM disks across multiple data stores. Now, when we start thinking about size, something that I don't have on these slides, but a single vVols data store can be as large as in the zettabytes. Because remember, a storage vVols container is what we call it on the array, is a logical allocation of space. Only the physical vVols themselves take up space. So you can see there's a lot of benefits with vVols. So let's go to the next slide. So go ahead and build this out. The way that this works is that usually your storage admin will go up and set up a storage container. That storage container, again, is a logical quota. And then that is presented to the vSphere environment. And this uses any of the traditional protocols. So iSCSI, FC, FCOE, NFS, whatever it might be. You can actually have the same, from the same array, vVols and some other combination of VMFS or NFS or whatever it might be. Once that's presented, next, then the VI admin registers the VASA provider, and there's usually tools from the vendor to do this. That VASA provider gets registered, and then these things called protocol endpoints are created, which is the actual IO path. And the VASA provider is then linked between the array and the vSphere environment. That's the bidirectional communication now between the two environments. Next. Then what happens is the storage capabilities are presented up. Click next. And then at that point, the VI admin can actually create storage policies based on security requirements, business organizational requirements, if it's a replication, if it's test and dev. Because remember, all of these VMs can coexist on the same data store, what looks like exactly the same data store, but they're not sharing a LUN or a volume. They each VM gets its own set of objects. Next. And then once that's created, you can go in and apply these policies to the VMs. And then when they get powered on, next, you'll see that the VMs are then passed through that protocol endpoint and then associated with their related vVol storage objects. And that's kind of a wrap up of all of the different functionality and features of vVols and how they work and how you can manage them. So next. So now Sudhir is going to jump in and tell you the big benefits that you can use with vVols and Oracle. Sudhir, it's all yours.
Thank you, Jason. All right, moving on to the next slide. So essentially, we will be focusing on the Oracle use cases using VMware virtual volumes. I'm going to move on to the next slide, right? And then even before we look at these use cases here, right, let's first take a look at some of the requirements business critical workloads have, right? And business critical workloads, and doesn't have to be the Oracles or the SQLs or the SAP of the world, right? Any business critical workload, they'll have certain SLAs, they'll have certain RTOs, they'll have certain RPOs, right? They'll have a set of stringent requirements, which includes, let's say, high availability, performance, recoverability, scalability, etc., with strict requirements for, let's say, day two operations to complete in a timely fashion. So what happens is when we start embarking on this journey to virtualize Oracle workloads, customers, they have certain concerns, right? And these certain concerns, they include, for example, if we were to look at day one operation, well, we have databases of different levels of criticality, need, and these databases, they need different storage performance, right? Different storage performance characteristics, they need different storage performance capabilities, right? Well, another day one concern typically is we need to meet stringent SLAs for performance with, let's say, slow traditional storage. Now, on the other flip side, when you start looking at day two operations, right, when it comes to, let's say, backups or clonings and so on and so forth, right, we have different set of concerns, right, which includes, let's say, rapid database growth. With the database growing very rapidly, what happens is there's a need to reduce the backup window to meet performance and also business SLAs, right? And with this rapid database growth, what happens? There's difficulty in cloning. There is difficulty in refreshing the data from production to QA and other environments because the database is growing in size with leaps and bounds, right? And what also happens is if one were to use what's called the storage-based replication, right? It's at a LUN level and the granularity is at a LUN level. And that actually causes unnecessary data to be copied over, even if one were to agree that the storage speed is superior, right? So focusing on day two operation, that takes a very big chunk of any DBA's time, whether that's a SQL DBA or an Oracle DBA, right? And these day two operation, right, they include, and it's not a conclusive list here, but it includes operations like backup and recovery, right? When we start using Oracle hot backup or cold backup, or even when we do consistent or crash consistent backup using storage based snapshots, right? Which includes, let's say, if one were to use Oracle RMAN, or let's say if you were to go with the Oracle data pump, the export and the import. The other day two operations could also be database cloning, right? Which includes use cases like I need to clone a new dev database for application development team, right? To test their existing application, or let's say the QA team to test their existing software for any kind of bugs, or I'm coming up with a new software feature, I need to test it. The other use case for database cloning could also be I need to test my backup and recovery scenarios to actually make sure that my backup and recovery mechanism that I have in place is actually working, right? Or I need to come up with different database copy for different business unit. Or I need to patch my database. I need to test the upgrades. I need to test the migration strategies, right? Or I even need to, let's say, benchmark database for certain performance. So you wouldn't be doing all of that in a real performance or in a real production environment. You would have to clone these databases and then run through these use cases to come up with benchmarks, right? And last but not the least, database refreshes, right? Essentially, which is like a usual task for an Oracle DBA to refresh the dev or the test or the QA database, because very soon at some point of time, the data becomes stale. So the day two operation, it takes a big chunk of an Oracle DBA or even a SQL DBA's time. And so these are some of the concerns that affect the Oracle workload virtualization in particular. All right, moving over. Okay, and let's say we were to pick up one day two operation in question today. Let's talk about the Oracle database backup and restore, right? Generally speaking, the regular database operation, for example, the Oracle database and backup, or that is not even specific to those, even cloning or even database, the refresh, that can happen or that can be triggered in three different ways, right? First, at the application level, which means at the Oracle database level. Second, at a VMware virtual machine level. And last but not the least, you can do the same operations at a storage level, right? Let's take backup and recovery as an example here today. Now, each of these three different levels approaches, they offer advantages and disadvantages. They have their pros and they have their cons, right? Look at the Oracle backup and recovery, for example, today. When we do the same backup and recovery at an application level or the Oracle database level, what do we have here? We have a finer level of granularity, right? Because you can back up a database at a tablespace level, at a data file level, or even have what's called the table level granularity. The cons to that, it's not always the fastest. When you come down to the next level, the virtual machine level, right? That's an ideal level because you want to take what's called a VM level granularity snapshot, right? Using the VMware based snapshot. But there's a KB article as well that basically talks about when we take a VM level snapshot and when we go to, let's say, coalesce a snapshot or delete a snapshot, there's a bit of a stunt time for the virtual machine, and that will affect the Oracle workload or any business critical application workload running in the virtual machine, right? And last but not the least, when we look at the storage array level, you know, the snapshot, we all know the speed is the ultimate, right? I mean, the performance is great, but what it lacks is VM level granularity, because what happens is all of the operations are executed at a storage LUN level, at a storage LUN level. And this is what we want, right? What we want is an ideal solution, right? Wherein we could combine the granularity of the virtual machine level snapshots, which is at the VMDK level, along with the speed of the storage-based snapshot. And what we have here is essentially virtual volumes, right? So combining VMDK level granularity with the speed of the storage array for any of these day two operations, right? Be that backup and recovery, be that cloning, be that database patching, be that database refresh, and so on and so forth. All right. So moving on to the Oracle and vVol discussion here today, let's have a look at the architecture design, and we'll talk about one of the use cases. All right. So this solution that focuses on virtual volumes, right? And we will examine the on-premises site B, which is the site to the right of the screen here for traditional Oracle single instance and even Oracle RAC setup, right? So if you look at the site B setup here, this essentially is a 4-node VMware vSphere cluster. The version is 7.x. Each ESXi server, that's a Dell, what we used was a Dell PowerEdge 630 servers. We had 2-socket 14 cores, 384 gigs of RAM, right? And each ESXi server, they had access to a pure storage flash array X50 for both block FC and also for vVOLS, right? And moving on to the next slide here, right? The thing that I would like to highlight here is essentially, when one uses Pure Storage X50, the feature that, one of the features that Pure offers is this Pure Storage plugin for VMware vSphere client. And so what happens is by using this plugin, right, you are able to enable the following operations. So for example, you are able to import a disk, right? You're able to import a virtual disk, a vVol, or you're able to restore a destroyed vVol, or you're able to take a snapshot, or you can override the existing contents of a VM from an existing vVol. And you're able to do all of that sitting at a virtual machine level. So you don't have to go down to the storage level. You don't have to have root password to the ESXi server. You are able to simply do that sitting at a virtual machine level. And that's the flexibility and the ability that this plugin were to offer. All right, so let's take a look at the first use case here, essentially database consistent backup and recovery using Oracle RMAN and vVol based snapshots. Okay, so we have two virtual machines in question here. The virtual machine on the left, that's the Oracle database server, right? It has a lot of VMDKs, but the VMDKs that are there in the red, essentially the data DG, the data disk group, and the FRA, which is for the archive log, and these are ASM VMDKs. They are the VMDKs that we'll be focusing on the use case here today. And the virtual machine, the operating system is 8.3 Oracle OEL, and that's using the Oracle 19.8 grid and the RDBMS binaries with Oracle ASM and Oracle ASM library. The virtual machine on the right, that's the Oracle RMAN VM. Essentially, we will be streaming our backups to the media server, the Oracle RMAN VM in question here today. And there's a mount point that's created here as well, /RMAN, and that's where we will be parking all the RMAN backup dumps. Again, the operating system used here was OEL 8.3, and the Oracle database and the grid infrastructure binaries with Oracle ASM was 19.8. And again, we're using Oracle ASM library. Okay, so let's look at the steps how we would do that using Oracle RMAN and Oracle RMAN on VMware Virtual Volume using Pure Storage and using the Pure plugin that we just spoke about a couple of slides before. So essentially, the step would kick off, right, by us, right, taking a snapshot. So what we would do is take a snapshot of the virtual machine, right? And once we take a snapshot of the virtual machine, what would then happen, right, is we would then import that disk snapshot to clone from, right? So we would then use that import disk option to clone from the snapshot, right? Which is the VM snap, right? That's been shown in the screen here, right? And then what we would then do is we would register the vVol 19C database that would have to happen, right? With the RMAN catalog, RMAN DB. And we would have already resynchronized the RMAN catalog with the production database, which would then add the most recent archive log info to the RMAN catalog. And then I already spoke about the fact that we would take the snapshot of the virtual machine. And once we do that on the RMAN virtual machine, so on the media manager or on the media repository virtual machine, we would then use the pure plugin option, right? The import disk. We would create two new VMDKs. We would create the data VMDK, and we would create the FRA VMDK from that snapshot that we took from the production Oracle database. So what do we have right now? So we have the RMAN virtual machine with two VMDKs, which is essentially the original VMDKs. And now we have two new VMDKs that are cloned from the virtual machine that belongs to the production database, right? And essentially, these are the steps that we would do once we attach the two new cloned VMDKs to the Oracle RMAN virtual machine, right? So once we do that, we would scan the new cloned ASM devices. And once we scan the new cloned ASM devices, essentially you would see four of them, right? You would see the two old or the two original VMDKs, and you see the two new VMDK or the clone of the VMDKs that belong to the Oracle production virtual machine. You would mount these up. You would start up the database, the vVol 19C in a mount mode, and then you would back up the Oracle database vVol 19C using the rman command to that mount point /rman, right? And then essentially at some point of time, you would then have a third-party backup software that will back up the contents of the /rman file system to any media manager. And once that's done, shut the database down on the rman virtual machine, dismount the ASM disk group, and you can delete the cloned VMDKs. And again, that's optional because remember, if that is something that we would have to do on a regular basis, you don't have to again delete it. What we can then do is the next time we do this operation, use the pure plugin override disk option to override the new added VMDKs, right? And these steps have been documented in this white paper that we released this year, virtualizing Oracle workloads with the VMware vSphere virtual volumes on a VMware hybrid cloud. All right. So assume that, and let's say if we did not have this pure plugin, right? What would the steps entail? Essentially, what we would have to do is, if we don't have this plugin, we would again take a snapshot of the virtual machine, the Oracle production database, right? But what we would have to do in this case here is we would have to use PowerCLI, right? Or we would have to manually clone the two VMDKs, right, from that snapshot using PowerCLI. And that could be we could use PowerCLI using the VMKFS tools, right? And then remember, the VM base disk, that's a point-in-time copy of the database, hence it is used as a cloning source. And then we would have to go to the RMAN virtual machine. We would have to manually add the two VMDKs as an existing disk, right? And now it would have four VMDKs, two VMDKs original and two VMDKs cloned from the virtual machine. And the rest of the steps are exactly the same as we said before, which means you would scan the bus to see the new VMDKs. You would mount the VMDKs as the new ASM devices. You would start up mount the Oracle database on the RMAN virtual machine. You would back it up to the /rman mount system. Once that is done, shut it down, delete the disk. If you don't want to delete the disk, you could then again use the import disk option if at some point of time you do decide to use the pure plugin. But a lot of advantages of using the pure plugin, the manual steps, those are not required. You can do with them away. And so that saves you a lot of time if you were to use the pure plugin, right? And all of these use cases that we did, right? Essentially, the database backup using vVOL-based snapshots, using Oracle RMAN, database restore and recovery using vVOL-based snapshots and Oracle mechanism, using database cloning, using again vVOL-based snapshots. If we have to refresh a database for the QA environment, or let's say a dev environment, test environment, again using vVOLs, database patching, right? And again, we did that for both the Oracle single instance and also for Oracle RAC database on vVOL using pure storage array, the flash array X50. They were validated, and these use cases are there in the white paper. The URL is there in the bottom of the slide here, and you guys will be getting the slide deck at the end of the session. And so, as in conclusion, right, Oracle workloads using VMware vVOLS, right? Essentially, as we see in the market here today among our customer base, among our partner base, the business critical databases, they are among the last workloads to be virtualized, primarily because of the challenges that are posed as the workloads they grow up and they scale, especially with day two operation, right? The fact that the database are increasing with leaps and bounds, right? The other challenge is meeting the strict business SLAs for performance, for managing rapidly growing production database, as I mentioned before, and making sure that if we have a backup window, right, we are able to reduce the backup window, or at least make sure that we adhere to the backup window. Because what happens is once that backup window, it overflows, that has an impact on system performance, right? And so because of these factors, because of these concerns, they force Oracle DBAs to delay virtualization of business critical databases and workload. Tack on to that the fact that there's a growing demand, there's a frequent demand for database cloning, for data refreshing, for database refreshing. That further complicates matter. So VMware Virtual Volume that addresses the challenges of day-to-day operation for these business critical huge Oracle databases, including backup and recovery, for cloning, for any kind of database refreshes, for any kind of database provisioning, right? And as I mentioned before, the reference architecture at the bottom of the slide that validated the day to operation for both Oracle single instance and Oracle RAC database on VMware Virtual Volume. We used pure storage flash array X50, right, with virtual volumes, and for all of the cases that I mentioned before. And as part of the wrap up, any and all Oracle on vSphere white papers, that includes Oracle on VMware vSphere or vSAN, or even VMware Cloud on AWS, virtual volumes, best practices, deployment guides, workload characterization guide, they can be found in the URL below. It's aptly called the one-stop shop, but essentially all KD articles, any blogs that we produce as part of the Oracle vertical, we dump it here at this particular blog site. So please do visit that when you get a chance. But here's a bit about me. And thank you for listening to us, and thank you for attending our session.
Yes, thank you. And as you can see, there's vVOLS really helps with why, like Sudhir said, a lot of DBAs were very resistant to moving to virtualization because there are certain functions that they wanted when they were doing bare metal, and you're able to do a lot of that with vVOLS.